Hey, what's up guys? I'm gonna do something different in this video, and I'm going to pick up where I left off in the previous lesson. So in Unit 8, Day 1, I said I was gonna talk about independent and dependent variables, and I never did, okay? And so this beginning part of this video is a continuation from the previous lesson, okay? And so really quickly, by way of review, we were talking about slope-intercept form, which is y equals mx plus b. And we said that the independent variable is the x, the dependent variable is the y, the m is the slope, and the b represents the y-intercept. Okay, and so what we're going to do is we're going to take these word problems and we're just going to identify what each part of the equation in the word problem relates to. Okay, so it says a cell phone company uses the equation C equals 0.15t plus 35 to determine the total cost C for a month of service based on the number of text messages T. Identify the slope, the y-intercept, the dependent and independent variables. Okay, and so we have our variables that are defined. It tells us that C equals the total cost. Then it tells us that T equals the text messages. Okay, so that's important for us to note, and in this one it is defined. Okay, and then it gives us an equation that is in slope-intercept form, and so we just need to remember that this is y equals mx plus b. Okay, and if we remember what each of these values mean, then it will be easy for us to indicate or identify which is each. Okay, so first we're looking for the slope. Okay, so the slope is m. Well, I just need to see what part of our equation matches with m, and that is the 15 cent. Okay, and so the 15 cent that you spend per text message, and that is going to be the key. You're going to see usually the slope is per or each. All right, and that's the slope in this situation. Well, then we can identify our y-intercept. Okay, and our y-intercept is the b. Okay, and so that is the constant that is by itself. Usually that's some kind of the starting point, or it is the flat rate or the fee that is separate. Okay, you just have to pay that and then you pay something additional. Well, the y-intercept is the $35. That is the b. Okay, so that corresponds to that. All right, and then we had to find our independent and dependent variables. Okay, so independent variable, okay, that is the x. So the x refers to what is with the slope. Okay, and in this situation is the t, which is text messages. Okay, so that is our independent variable. Okay, and then our dependent variable, okay, is the y. Okay, and the y in this situation is our total cost. So again, all I did was I looked at our equation. Remember that this is y equals mx plus b, and again, you do have to keep in mind and remember what each piece means in order to be able to identify them. Okay, so here's what I got to do. I'm going to do the next example, but it's actually not updated here. So I got to move this over, and here is our next example. Okay, so I want you to take our next example. I want you to read it, and then I want you to identify and do what it says. So pause the video and see if you can identify the slope, the y-intercept, the independent and dependent variables in this situation. Okay, in order to join a dancing club, there's a $30 startup fee and a $4 monthly fee. The equation T equals 4M plus 30 shows the T total cost for M months of a membership. Identify the slope, the y-intercept, the independent and dependent variables. Okay, so again, we have T, or we can do a capital T here, T equals the total cost, right, after the membership. M equals the months, right, the months of the membership, okay, and then we have our equation is T equals 4M plus 30, okay, and if we remember Y equals MX plus B, that's going to help us identify each. Okay, so our slope in this situation, right, it is the M, okay, and that is the $4 monthly, okay, so each month you have to pay the $4, that's the slope, okay, is the 4. Then the y-intercept, okay, that is going to be the B, okay, which is the $30, all right, that's the $30, the startup fee, okay. I'm gonna just write this here. I think that could be helpful. Startup fee. Okay, that's the y-intercept. All right, and then the independent variable. Okay, that is going to be the x, the independent variable, and that is what's with the slope. And the independent variable is the number of months, while the dependent variable is the y, which is in this case the t, which is the total cost. All right, okay, and so there you have it. Hey, that's all the examples I have for that. We are going to continue that with more practice later, but now we are officially in day 2. So with that said, what's up, chat? Welcome to Unit 8. Day 2, we're going to be looking at linear translations, and here's the deal. I know I just spent a few minutes covering the previous lesson, so I'm just really going to do one problem to give you one main idea in this lesson. And so in this lesson, we're just going to learn when we add a constant or b to an equation y equals mx, how is that going to affect it? Well, it's going to translate it on the line, and we're going to see that. All right, so I'm going to start with just this situation, and this is the only problem that I'm going to cover in the remainder of this lesson. Okay, so if I gave Dazon 2 Blair bucks per day for his good behavior, all right, the equation y equals 2x shows the total number of Blair bucks, all right, and this equation is shown on the graph. Okay, so you see this is graph, all right, at first day he gets none, then after the first day, I'm sorry, on the first day he has, or zero. On the first day he has 2, right? After day 2 he has 4, okay? After day 3 he has 6. So this graph shows the number of Blair bucks that he would get, okay? Well, my homie Najee, he already has 3 Blair bucks, but Mr. Redmond also agrees to give him 2 Blair bucks for his good behavior. Well, the equation that represents the total number of Blair bucks Najee will receive is y equals 2x plus 3. So they're both getting 2 each day. Najee just starts off having 3. And so what we want to do is we want to do 2 things. First, we are going to kind of put in a table this situation, right? So we have my man Dazon's, right? On day 0, he has, or 0, he has none, okay? Before this starts. Well, after day 1, he has 2. After day 2, he has 4. After day 3, he has 6. Right? Easy. Okay? Well, this is, again, so this is Dazon, right? This is Najee, okay? And after Najee, he has 2 each day, but then he also adds 3. So before I start this initiative on when I put in a 0 for the x, that's going to be 2 times 0, which is 0, and then it's going to be a plus 3. So before I started giving the 2 Blair bucks each day, Najee already had 3, okay? Well, then let's continue on after day 1. After day 1, Najee gets 2 Blair bucks, but he plus the 3 he already had, so he has 5, okay? And so, again, you could finish this out, right? But I'm going to take that number, 2 times 2, I get 4. I have 4 after day 2, but I also had 3 to begin, so that is 7, and then 3 times 2 is 6, plus 3, and that is 9. Okay, so this third line or third row of our table shows what the really what the points are going to be for Najee when he already starts with 3 Blair Bucks. And so now what I want us to do, this is already drawn. It has designs. Now we're going to draw Najee's graph and look at it and see what's the relationship. Okay, so on day 0, 0, Najee he starts at 0, 3. Okay, because again on days this is Najee, but he starts 0, 3. Okay, because he already had 3 Blair Bucks. On day 1, Najee's point is 1, 5. Okay. On day 2, Najee's is 2, 7. On day 3, Najee is 3, 9. Okay. So then I can just connect all of my points. Okay. All right. And now it just simply asks me what happens to the graph. What happens to the 2x, y equals 2x, which was Dejan's, when a constant 3 is added. And here's again, if I was going to ask you, matter of fact, I want you to pause this and I want you to tell me, what do you think happened? Okay, it's not rocket science. It's pretty straightforward. What happened to the graph? How would you describe what happened? Go ahead and pause it, and then I want you to write a response here. All right, cool. And so maybe you said something along the effect that the graph, or we'll say the line moved up. Yeah, you said the line moved up, right? So it was here, now it would be shifted up. Well, I would say how many did it move up? Well, you can say maybe it moved up 3 units. Or 3 spots, okay? And here is the key point, all right? Here's the main point for the lesson, and this is one that you will need to remember. When you add a constant, so when you add a b, okay, the line will translate. That is the word that means move up, and we're going to talk about that later in the unit, but it translates, it slides, it moves, and it moves up or down, okay? It moves along the y-axis, up or down, based on the constant. So because we added a positive 3, that, if you will notice, it shifted the whole line up 3, okay? If we had added, say we added a plus 5, well, it would have shifted it 5 up. Or imagine we took away, right, and it was minus 2. Then that would have shifted it down 2. It would have translated it down 2, okay? And so, guys, I'm going to tell you, this will be an exact test question. So you will need to remember this right here, okay? So when you add a constant, it is going to translate it vertically, all right, based on the constant, whatever that number is, all right? Hey, I know there's not any other examples to do here. Those are the big ideas, but we're going to do some additional practice. So use these notes to help you answer the following questions that come after this related to this topic. Hey, in this lesson, we have learned what happens when you add a constant to an equation in slope-intercept form.